Okay, hello everyone. This is the video for Geometry Honors, Tuesday, April 7th, April 7th, excuse me. These are real world problems, real life problems. So, real world problem number one. This was on a Regents a little while back. And this first part is more long than it is difficult, okay? The water tower in the picture below is modeled by the two-dimensional figure beside it. The water tower is composed of a hemisphere, a cylinder, and a cone. Let C be the center of the hemisphere, and let D be the center of the base of the cone. So now, we're going to need some information to be able to do this. Let's just see this. If this is 8.5 here, then this is also 8.5 there. Because in a sphere, every point on the sphere is equidistant from the center. So each one of these points would be 8.5 from the center. That would make this 8.5 over here as well. And then we need to find out this. That's going to be part of the equation that we're going to need. And here's a right angle. That's opposite. That's adjacent. Which one uses opposite and adjacent? Tangent. So the tangent of 47 degrees is equal to x over 8.5. Put this over 1, cross multiply. X is equal to 8.5 times the tangent of 47 degrees. So x is equal to 9.115134035. Okay, so that's that. Now, to get the volume of the entire figure, we're going to have to add the volume of the cone plus the volume of the cylinder plus 1/2 the volume of a sphere. So I'm going to write that out. Volume is equal to the cone plus the cylinder plus 1/2 of the sphere. So the volume of a cone is 1/3 pi r squared h. The volume of a cylinder is pi r squared h. And the volume of a sphere is 4/3 pi r cubed, but it's 1/2 of that. And then we got to start filling everything in. The radius of the cone, okay, right here, 8.5. The radius of the cylinder is also 8.5. And the height of the cylinder, right here, the height is 25. Plus 1/2 times 4/3 pi, and the radius over here is still 8.5. Okay, so, and I missed out something. Sorry about that. I didn't put the height in the first one. Some of you might have noticed that. It's really volume equals 1/3 pi times 8.5 squared times the height, which is that whole value, 9.1151. That's all I could fit in here for now. You could do the whole thing, but I ran out of room from up here. Okay, you do this all out, you get volume is equal to 689.6512514 plus 5674.501731 plus 1286.220392. Okay? You add that all together and to the nearest cubic foot, and you end up with 7,650 cubic feet. So that's the first part. And of course, on the Regents, I believe this was a 6-point question at the time. There was partial credit everywhere. And what I always reminded my students after, and if we were in class, I would say, let's say you got stuck and you didn't know how to get the height there. You could even say, let x equal 5, and then do the whole problem with that value. And you'll just lose whatever it was to find that one value. But you can't just stop the problem and not continue to do anymore. You must always keep going. The second part of this question was probably harder than the first. But now again, we use whatever we get here, and then you do everything accordingly. The water tower was constructed to hold a maximum of 400,000 pounds of water. If water weighs 62.4 pounds per cubic foot, can the water tower be filled to 85% of its volume and not exceed the weight limit? Justify your answer. So we have 7,650 cubic feet from earlier. We multiply that by 62.4 pounds per cubic foot, which came from the question over here, right? Okay, the cubic feet cancel out, and you end up with 477,360 pounds. We multiply that times 0.85, 85% of the volume, and you end up with 405,756 pounds when it's 85% full. So, no, it will exceed the weight limit. Okay? No, it will exceed the weight limit because this number is greater than 400,000 pounds. Okay, so that was the first one, the water tower problem of the real world problems, okay? Next, trees that are cut down and stripped of their branches for timber are approximately cylindrical. A timber company specializes in a certain type of tree that has a typical diameter of 50 centimeters and a typical height of about 10 meters. Okay, so right away we have, this is in centimeters, this is in meters, okay? The density of the wood is 380 kilograms per cubic meter. Kilograms, that's important to know. Per cubic meter, that's important to know. Very important because we need to use meters if this is in cubic meters. And the wood can be sold by mass at a rate of $4.75 per kilogram. So you always in the problems want to make sure you go through them so you know what you need to do. And if you have anything that doesn't match, such as the centimeters and the meters over here. Determine and state the minimum number of whole trees that must be sold to raise at least $50,000. And guys, some of these problems are hard, and the Regents actually put on, every year they put on some really challenging ones. Back in the day, people were able to get hundreds on the Regents. It's not so common anymore. Anyway, so here we go. I'll draw my cylindrical branch over here. And it says the height is 10 meters. And it says that the diameter is 50. So right here, that's 50 centimeters. Okay. So then I take the 50 centimeters and I want to convert it to meters. Well, 1 meter is equal to 100 centimeters, right? I can't multiply those, the centimeters cancel. 50 over 100 is equal to 0.5 meters. So the diameter is 0.5 meters, because that's a diameter, which means that the radius is half of that, so it's 0.25 meters. And the height we have from here, the height is 10. They gave us that in the problem. So, volume of a cylinder, we all know the volume of a cylinder is pi r squared h. So it's pi times 0.25 squared times 10. So the volume is equal to 1.963495408 cubic meters. Okay, are we done? No. Density is equal to mass over volume. Okay, density is equal to mass over volume. They told us that excuse me, I'm videoing. Density is equal to mass over volume. So we know the density is 380 is equal to mass over volume. We found the volume right over here, 1.963495408. Put this over 1, cross multiply. The mass is equal to 746.1282552 kilograms. Okay? Now, it's $4.75 per kilogram. We have this many kilograms. So we multiply this times $4.75 per kilogram, and we end up with $3,544.11 per tree. So we need to make $50,000, okay? And they make $3,544 per tree. So how many trees do we need? 50,000 divided by $3,544.11 is approximately 14.1, but the answer, you cannot say 14. You're not rounding it here. You're not rounding down, because if we need 14.1 trees, well, it has to go by whole trees. In the question it says whole trees. So I need 15 trees. 15 trees. Okay, so that's the answer to that one. Okay, number 2. Hold on one second. I'm videoing, please. Number 2, a snow cone consists of a paper cone completely filled with shaved ice and topped with a hemisphere of shaved ice, as shown in the diagram below. The inside diameter of both the cone and the hemisphere is 8.3 centimeters. That's for the diameter. The height of the cone is 10.2 centimeters. The desired density of the shaved ice is 0.697 grams per centimeters cubed. So let's see. So we had centimeters here. That was good. And centimeters here. And then it was the cost per kilogram. Okay. So to do this next problem, what you're going to have to do is the volume of a cone plus 1/2 the volume of a sphere. The volume of a cone plus 1/2 the volume of a sphere. You're going to get the volume of the whole thing, and then density is equal to mass over volume, right? And they give us grams per centimeters cubed, so we're going to take, we're going to do 0.6, we're going to do the 0.697 equals the mass over the volume that we find in this problem. Then you're going to get the mass, you're going to convert that mass into kilograms, and then you're going to multiply that by $3.83, and then multiply that times 50. So there's a bunch of work to do here, but if you listen and follow the steps that I said, you'll be okay. what you have to do for your homework on this one, you're going to do number 2 and number 4, 5, and 6. You do not need to do number 3. You're going to do, your homework is numbers 2, 4, 5, and 6. Okay? Hope you are all well. And then this will be due tonight. So that's Tuesday night. This is due, numbers 2, 4, 5, and 6. Be safe. Miss you all. Have a good night or a good day. Bye.